All right, welcome back, class. This is 9.1b, and today we will be writing exponential functions. And then one thing I want to be clear about, I think in the last lesson I didn't clarify that if it was a decay, it's between 0 and 1. So it's still greater than 0, but less than 1. So that's if it was, like for this parent function, y equals half to the x power. Just like with the vertical stretch and shrink, if a is greater than 1, it's a vertical stretch, and if a is less than 1 but greater than 0, then it's a vertical shrink. So I just wanted to clarify that. That also can segue into the beginning of the lesson. We want to remember this, that if it's greater than, this should be 1 here, it's a growth if it's greater than 1. And it's a decay if it's between 0 and 1. So I just thought we would go over that quickly. And then we should be able to identify if it's a growth or a decay. So in this first case, my b is 1/3. 1/3 is less than 1, so that's a decay. 3, this is what we will call number 2. I'll just label each one here. Number 2, b is 3, and 3 is greater than 1, so that would be a growth. Half is less than 1, so that would be a decay. And then let's make sure we look in depth on this last problem. B looks as though it's half, but it's to the negative x power. So because it's a negative, we want to take the reciprocal. So that'd be y equals -4 times, and remember, this negative number, this is not raised to the negative power. So this will stay the same, just this quantity here, that we will take the reciprocal of. So that becomes 2/1, or just 2 to the x power. So now we can see our b, which is 2, is greater than 1, and that means it's a growth. So be sure to look in depth at what it is asking, and if it's a negative exponent, then we need to take the reciprocal, and then we will see that it's a growth factor. So when writing exponential functions, we want to create a system of equations, and before we do that, I would like us to look and see if this will be a growth or a decay by plotting these 2 points. So 1/4 would be right about here, and then 2/12 would be up here. So we can tell that this will be a growth factor. So our a should be, or excuse me, not my a, that won't imply that. My b should be greater than 1. That's what that will imply. So keep that in mind when we are writing our equation. These are both ordered pairs, so we can use them to substitute into our standard form of the equation. We're going to be plugging in where we see y and x, and I'm going to keep them on the left and the right. And then up at the top, I'm just making it clear it's going to be a system of equations. Then we will then solve using substitution. So I just wanted to be clear about that. So off to the left, I'm going to do this first ordered pair for plugging in. So plugging in for y and x. So y is 4. So 4 equals a times b to the first power. And then over on this side, I'm going to do this other ordered pair. Y is 12 equals a times b to the second power. That's a 2. Now, this next step, I highly recommend doing it this way. Whichever exponent is lower with the b's, then we're going to substitute or solve this way. When we solve, we're going to be solving for a, so we want to isolate a. So we would want to divide both sides by b to the first power, which is just b. So we have 4b over b equals a. Now that we have found what a is, we can substitute my a into this function. So it's 12 equals, we found a is 4 over b times b squared. We can also think of this product here as b squared over 1, so we can multiply straight across. So that would be 12 equals 4b squared over b times 1, which is b. And now this goes back to last unit. Since we have the same base and it's a quotient, we can subtract our exponents. So that would be 12 equals 4b, since it would be b squared over b to the first, so all that remains is a single b. Now we can solve for b here. So it's a product. The inverse operation would be to divide both sides by 4, so then b equals 3. Okay, and we're not done yet because we're trying to write the standard form of the equation. So we found a b, we still need to find out what a is. So right at this point, since we have a b, I'm going to use a different highlighter, we can plug b in here to solve for a. So it would be 4 over 3, since b is 3 equals a, and we've already found a. So I have my a and my b, and from there we can write our standard form of the equation. So that would be y equals whatever a is, so 4/3, times 3, because 3 is b, to the x power. And this is my standard form. And again, going back to the beginning, we said it would be exponential growth based off our graph we drew. So b must be greater than 1, and it is. So that looks pretty accurate to me. All right. And in this second example, we're going to take those same steps. So let's start by graphing it just to get an idea. So we have 2, 9. We'll call that way up here, and then 4, 20. Yeah, okay, so this is again going to be a growth factor here. We have an ordered pair of xy and another ordered pair of xy, so we can substitute xy in for xy to our standard form. We're going to keep them on separate sides and then solve using substitution. So my first side, I'm going to do this one. Y equals, y is 9. 9 equals a times b to the second power. And then off to the right, we have our other one. Y is 20.25 equals a times b to the fourth power. Again, we want the smaller power in the denominator when we substitute. So I'm going to isolate and solve for a on this side. So my inverse operation, we're going to divide both sides by b squared. So these simplify. So we have 9 over, b squared equals a, and then we can substitute a in right here and solve for b. So 20.25 equals 9 over b squared times b to the fourth. We're going to do it the same way where we multiply straight across on the right. So 9 times b to the fourth is 9b to the fourth over b squared. Now when we take our quotient property, it's 20.25 equals 9b to the b squared, because 4 minus 2 is 2. Or we can visualize it as b times b times b times b over b times b. And we only have b squared left in the numerator. Okay, and then now we can solve for b. So we're going to divide both sides by 9. I've already solved this. 20.25 divided by 9 is 2.25 equals b squared. This goes back to solving to last unit, so we're going to want to do the inverse of squaring, which is the square root. The square root of 2.25 is 1.5. If you're wondering why this is not positive and negative, it's because it's the absolute value of b. And if it's the absolute value, we want strictly positive values. So that's why it's going to be strictly positive here. Okay, and we're almost done. We found a b, so now we can use that and plug it in here to get our a. So 9 over 1.5 squared equals a. So it's 9 over 2.25 equals a, and I already solved this as well. 9 over 2.25 is 4. So that's a nice number. And then we have our a and our b, so we can write our standard form, which is y equals a times b to the x. So when I substitute, I get y equals 4 times 1.5 raised to the x power. And again, in this case, it is a growth, and we can confirm it. Our b is greater than 1, so this function here looks good for our ordered pair points that we had. All right, thanks for watching. Let me know if you have any questions, and I'll see you later. Bye.